question says that figure 3.1, here in the figure you can see figure 3.1 shows a gas trapped in a sealed end of a tube by a dense liquid. Here you can see the tube is open on one side and closed on other side. And on the left side you can see a gas trapped in this tube. And the volume of gas is being shown as 60 centimeter cube. Are you seeing on the screen this 60
हाँ.
centimeter cube? Okay. So now statement. The scale marked on the sealed end, mean on the left end of the tube, is calibrated to read the volume of the gas trapped above the liquid surface, which shows that the initial volume V1 of the gas is 60 centimeter cube. So initial volume V1 is given, which is 60 centimeter cube. The pressure of the atmospheric pressure, which is 1 times 10 raised to the power 5 Pascal. Okay, now move to the table.
हाँ.
How figure 3.1 shows that the pressure of the trapped gas is equal to the pressure of the atmosphere. How you can say
Because
by seeing
how
figure?
do you show the pressure? Because they're both equal.
Yes, the level of the liquid in both columns is equal. That's why you can say that the atmospheric pressure is equal to the pressure of the gas trapped. Okay.
हाँ.
Okay, next question says, explain in terms of the momentum of its molecule. Why trapped gas exert a pressure on the walls of the tube? So why it exerts pressure?
Because the gas molecules collide with the walls of the container. So
And due to that collision, what happens? Change in momentum. And when change in momentum happens, then change in momentum is related to the force, because force is equal to change in momentum per unit time. So when momentum change, then force change. And when force change, then pressure change, because pressure is force per unit area. Is it okay? Let me not mean force is equal to change in momentum per unit time. So when this momentum change, then force change, and pressure is equal to force per unit area. So with the change of the force, the pressure change. That's happened here. Is it okay?
हाँ.
Okay, now move to the next question. Next question says that more of the dense liquid is poured into the open end of the tube. Mean now the more liquid is being poured on open end. Okay, as you can see in the figure here. No, there will be more liquid. Okay, the level of the liquid
हाँ.
surface in the both sealed and open ends of the tube raises. As shown in the figure, the temperature of the trapped gas and atmospheric pressure both remains constant. Okay, no. In
हाँ.
the sealed end of the tube, the volume V2 of the trapped gas is 50 centimeter cube. Mean the final volume, mean V2 volume is given, which is 50 centimeter cube. In the open end of the tube, the liquid surface is 15 centimeter above the new level of the sealed surface. Okay, calculate the pressure P2 of the trapped gas. So we will use P1 V1 is equal to P2 V2. What is
P2
P1?
V2.
P1 is atmospheric pressure. V1 is the initial volume, which was 60 centimeter cube. P2 is to be calculated, and V2 is 50 centimeter cube. So we will just substitute the values and we will get the answer. Let me substitute it. So here P1 is 1 times 10 raised to the power 5 times 60 centimeter cube, which is equal to P2, which is being calculated, times what is V2? It is 50 centimeter cube. Okay. So for P2,
हाँ.
it will be equal to 1 times 10 raised to the power 5 times 60 divided by 50. So when you divide it, I will get the answer which is equal to 1.2 times 10 raised to the power 5 Pascal. Have you got this thing?
हाँ.
So 1.2 times 10 raised to the power 5 Pascals. Is it okay?
Yes, sir.
Okay. Next question says that calculate the density of the liquid in the tube. So here we have to calculate density. How you will calculate? Can you tell me some formula or some method?
So the formula I know is density is equal to mass over volume.
Mass over volume. So is mass given in this case?
No.
Then which formula do you will use? Here you will use formula of a depth of the liquid, which is equal to, sorry, density is equal to rho gh. You will use this formula. Mean pressure with depth. Pressure with depth is equal to rho gh. But here are two pressure. One is atmospheric pressure, and other is the pressure due to liquid. So you will add up these two pressures. Have you got this thing?
हाँ.
Is it okay? So it will be P2 or P will be equal to atmospheric pressure, which is 1 times 10 raised to the power 5 plus we have to calculate P2. Sorry, P2 is also given. P2 is what is pressure P2? It is which we have calculated now. 1.2 in above question. 1.2 times 10 raised to the power.
So I've never seen this formula.
Why are you saying?
I have never seen this formula.
Have you seen this formula? P is equal to rho GH pressure with depth.
Ha ha ha.
So for liquid, but here given in the question that atmospheric pressure is also acting on that gas. So that's why we will just add atmospheric pressure, just add up it. Have you got it now?
Ha.
So 1.2 times 10 raised to the power 5, which is P2 means final pressure, is equal to atmospheric pressure plus raw mean density, which is to be calculated. What is G? G is 10, and what is H? H is given in the question, which is 15 centimeter. Is it okay?
Ha.
Okay, 15. Here I have to
Ha.
find raw. So first I will subtract it. So raw mean density will be subtracted. So it will become 1.2 times 10 raised to the power 5 minus 1 times 10 raised to the power 5 divided by 10 times 10, 15. Is it okay? Have you got this
Ha.
thing? How I have written all these things?
Ha.
Okay, so you will get the density which is equal to 1.3 times 10 raised to the power 4 kilogram per meter cube. By the way, for getting it in meter cube, you will divide it, take this 15 as 0.5, 1.5. Is it okay? Because this is
Ha.
15 centimeter. So here you will write 0.15 to get it the answer in meter cube. Is it okay?
Ha.
So our density will be 1.3 times 10 raised to the power 4 kilogram per meter cube. Is it okay?
So why do we add atmospheric pressure?
Let me give here. Are you seeing this figure?
Ha.
So in this figure here you can see that one pressure it is due to this liquid. One thing, and other pressure it is due to atmosphere which is acting at this point. So that we have to calculate the total density. So for density here two pressure are acting. This is pressure due to liquid, and this is pressure due to atmospheric pressure. That's why we add up these two that pressure. Is it okay, or any confusion here again?
No confusion, sir.
Now move to the next. Next question says that water have a water have a heat capacity of 4200 joule per kg and boiling point of 100 degree centigrade. What is meant by boiling point?
At temperature or a liquid becomes gas.
Okay. Next question says that a mass of 300, oh sorry, 0.30 kg of water at its boiling point. So what is boiling point? Boiling point is 100 degrees centigrade. Is poured into copper container, which is initially at 11 degrees centigrade. Okay. After a few seconds, the temperature of the container and the water both are 95 degrees centigrade. Okay, calculate the energy transfer from the water. So how you will calculate energy transfer from water?
From water, E is equal to del M. So energy is equal to mass times by specific heat capacity times by change in temperature.
Yes. So what is M here? M is 0.30. What is C? C is given, which is almost
More.
4200, which is 4200. So 4200. And what is
So
delta T?
where's the thermal heat capacity?
Thermal capacity is given in the A part. Are you seeing this one? Here this is given. And you can remember it because it's being used in many of the questions.
Uh,
Have you seen heat capacity given in the question?
oh yes. So, sorry.
Okay, okay. And I am asking that what is delta in this case? Delta T, delta means change in temperature in this case. Because here are three
So it goes
temperatures are.
95 minus 11.
Repeat again. I am saying that here three temperatures are given. One is the two temperatures are for water and one temperature is for container. Which two temperatures you will use for change in temperature?
95 and 11.
Why 11?
Because it is initially at 11 degrees, but then after a few seconds, temperature of container are both 95 degrees. So 95 minus 11.
So initially water is at what temperature? Read again the question. Water is at what temperature? It is at its boiling point.
Oh, 100.
Yes, it is at boiling point. It's 100.
That's why I lose marks. Oh, okay.
So you will just subtract it. 100 minus. What thing you will do minus?
100 minus 95.
95 or 11.
The water at its boiling point, which is initially. So the copper container is 11.
Yes, sir, copper, because here we are going to calculate the energy transfer from water to container. That's why we will take it 11. Is it okay?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay. Now you will just have to multiply it and you will get the answer. 0.30 times 4200 times 89. Is it okay?
Huh.
So let me calculate it. It becomes almost 1.12 times 10 raised to the power 5. 50. Is it okay?
Huh.
Next question says that calculate the thermal capacity of copper container. So we have to calculate thermal capacity. How you will calculate thermal capacity?
We try to find thermal heat capacity of then C equals E over. So I think C is equal to E over M delta T. You forgot the mass.
Let me it first let me write. E is equal to mc delta t. Okay, and by the way, this thing is known as C. Is it okay?
Oh, okay, okay, sir. Yes, I get you.
Okay, that's why
Can I just
yes,
write it?
yes, E over delta t. Okay, so our C will be
Oh,
what?
okay.
E is 1.12 times 10 raised to the power 5, and what is delta t? So here tell me what will be the delta t for this container?
For the container, so then the transferred is 1.12 times 10 power 5 divided
So
by
what was the initial temperature of the container and final temperature for container?
so initial temperature of container is 11, final temperature is 95.
So 95 minus 11. Is it okay?
Huh.
So you just multiply it and you will get the answer. And by the way, it will be 7.5 joules per degree centigrade. Is it okay?
Huh.
Now move to the next question. Next question says that water from the container evaporates and the temperature of the remaining water decreases slowly. Okay. Explain in terms of the molecule why evaporation causes temperature of the remaining water to decrease. It's very simple question. Why mean evaporation causes cooling? He's asking this point.
Because evaporation allows the high energy molecules to escape from the surface, only leaving behind lower energetic molecules which are cooler than the ones that have left the surface.
Very good, very good. Okay. The next question says that the distance between the center of a thin converging lens and each principal focus is 5 centimeter. Okay. Describe what is meant by the term principal focus of a thin converging lens. So here you have to just define principal focus.
Principal focus is the distance from, oh, it's where they meet after passing through a lens.
Yes, it's at the point where all the rays passing after passing from the lens they will meet. Okay.
Yes, sir.
Next question says that the lens is used as a magnifying glass to produce an enlarged image of object. Okay, underline the terms which are which describe the image produced by the magnifying glass. So, what are the points for magnifying glass?
It's a converging lens, and so is there a picture of the lens, or is it there's no picture?
It is he is telling that it's a magnifying glass in the question.
Oh, it makes it bigger. So then, when it makes it bigger, it is enlarged.
Okay, very
It
good. Next.
is it is not inverted. It is
Okay, real.
upright,
Very good.
and it is virtual.
Very good. It's virtual. So these three things. Okay, next question. Next question says that figure 5.1 is a full scale diagram of the lens and image. So here you can see this is the lens here. Here this is the lens and this is image produced by this lens. Okay. Now move to the question. Question says that on figure 5.1 mark the both principal focuses and label each of them as 5. So here small 5 box show 1 centimeter on horizontal and small 5 boxes on vertical also show 1 centimeter. So focus point is 5 centimeter. So it will appear at this point. Have you got this thing? At this point on the right side and similarly on this point of left side. Is it
Oh,
okay?
yes, sir. Yes, sir.
You will just calculate it.
Huh.
Okay.
Huh.
Okay, next question says that by drawing on the figure 5.5, find the position of the object. Mean we have to find the position of the object O and add the object O to the diagram. Mean he said that find the position of the object. So for finding the position, what you will do? We will just take two lines. So one line that will pass from the top of the image through through the center of the lens. So let me change its color for better. For better understanding, let me change its color. Let me take it yellow. Okay. So one line will pass from the center. No, yellow is not appearing correctly. Let me make it. uh, hmm, so this color. Okay. So one line will pass from this thing and it will pass through the center of the lens, and second line will go from image to at this point, and after reflection it will pass through from focus point, and you and after from this point we will draw a line, because initially these rays are going parallel. So where these two rays meet at this point, so at this point we will have an object and we will label it as O. Have you got this point?
Huh.
Are any confusion in this question?
No, no, sir.
Okay, then move to the next question. Next question says that determine the distance of the object O from the center of the lens. So here you will calculate this distance. By the way, this is this is 5 centimeter, and this is again 5 centimeter. It's 10 centimeter, and it's uh, 10, 12.5 or 13 centimeter. Is it okay? It's almost 13 centimeter. Have you got this thing?
Yes, sir.
So it's almost 13 centimeter. Is it okay? So
Huh.
So let me write. It's about 13 centimeters. Okay, now move to the next question. Next question says that the speed of sound in air is 340 meters per second. Okay, calculate the range of the wavelength for the sound that are audible by a healthy human ear. So what is the range of sound waves?
So I actually don't even know.
Mean here asking what is audible range of human ear?
Uh, I think 0 to 20,000. No,
No, 20 to 20,000.
2,000.
Yes, 20 to 20,000 hertz. Okay,
Oh, yes, sir.
20K hertz. Okay, next question. Next question says that sound waves are longitudinal. Describe how a longitudinal wave differs from a transfer wave. It's very simple. Can you explain how?
A longitudinal wave is. Sir, I know transverse waves are circular, while longitudinal waves have.
Why transfer waves are circular? By the way, can you give an example of
No,
transfer waves?
wait. Transverse waves are like, what's it called? Oh, sound waves.
Sound waves are longitudinal, not transfer waves. Why are you confusing?
No, sir, I know something that looks like a transverse wave is sine.
Yes, it's localized sine waves. So I will give you that water waves in a pond or in a lake are example of transfer wave. So can you predict the direction and the motion of the particle for that wave produced in a lake?
Uh, they go like, what's it called? In a wait, in a pond.
Yes, in a pond or in a lake. They
They
will look
go
like this.
like,
Let me tell. They will look like this.
huh?
So in this way they are going, and This is showing their direction. So the motion of the particle is perpendicular to the direction of the propagation or direction of the wave. So that is the one difference. That in sound waves or in longitudinal waves, direction of propagation and vibration of particle is in same direction. But in transfer waves, direction of motion and vibration of the particle both are perpendicular to each other. Have you got this difference?
Huh.
So this is the main difference
Oh,
there.
okay.
Is it okay?
Hmm.
So second difference is that longitudinal waves consist of compressions and rarefactions, while on which things that transfer wave consists of.
Transverse waves have crests and troughs.
Very good. Transfer waves have crust and trough. Longitudinal waves have compressions and rarefactions. So these are the two differences. Okay.
So we have to go now.
You have to go now.
Yeah, unfortunately.
Okay, no issue, no issue. You can go. Okay.
Thank you. Yes, yes.
Okay. Bye bye.